when it comes to designing a part, sometimes you want to actually see how the part will function or even look like. So that is when rapid prototyping comes in. And in this case, we're showcasing the 3D printing. So once you finish your design in your CAD software, like SolidWorks or Inventor, you can import the model into the 3D printing software here. In this case, I already have two models here. So this is how it will look exactly the same as you can as you will see in your CAD model. And then this cube here, once we get the model inside this tray will look exactly the same as the ones we'll be using in the printer. The next step is to change the model setting. So there's a couple things you can change. Is the model setting, and then the layer accuracy, and then the model orientation, and then the scale, and of course the density of the model. In this case, when we want to print something like this, so the structure integrity is not very important, but the finish is more important than the function. In this case, we can change the model setting. It defaults to high density, but in this case we don't need it, so we can go as low as possible to the low density setting, which is the infill density is 13%. And then the support material, we usually let the computer do the calculating, so we pick the smart support style. You can actually drag this model on this tray, so when the model is being printed, it will print exactly where you want it to be. In this case, this cube is sitting on the flat surface, and this is good. And then the scaling, we can scale the model. If you design a CAD model to be like 2 inches, but you actually want it to be 3 inches, you can scale here and print it. And for this part, it is a little bearing. It's a functional part. So the surface finish is somewhat important, and then the structure integrity is even more important. So in this case, we change the setting here. We want the tray setting to be a little bit higher, so the slice height, we reduce the slice height to increase the accuracy of the model. We can change to 0.7, so that way each slice will be much thinner, which is increased accuracy. And then for the model setting, we want a high density for this model, but we don't need to go full solid, because the bearing doesn't apply much force when we test the part. And then for the support material, we go with the same style, smart style, and then the arrange is just sitting here is fine. Now the orientation for this part is very important. If you import your model and it looks like this, it can still be printed, but it won't come out as accurate as you want it to be, because the way the printer works is they print it layer by layer. So this, you can see the circle profile here. When we finish printing, the surface finish will not be as smooth as you want it to be. To get the best result, we actually want to lay it flat. In this case, using a less support material and has a good finish. And then of course the scaling. In this case, it's good to go. So after that, we give it an estimate. So after you finishing calculating, it will give us how much time this part needs to be finished printing, and then the model material you'll be using, and then the support material as well. If that satisfies your need, we can move on to send this file to the printer. So after the printer receives it, it will show it here, and you can click on it and it will show the time, the material usage.
I have question about the setting. You're talking about you make the setting for two different material for like a density and different layer depend on angle. So how you make a setting for increase accuracy of the 3D printing result?
To increase the accuracy, we go to model setting here. There's two ways to do it. In model setting, you can increase the infill, which is how much plastic it actually will be injected inside. It will be printed inside the model. The more material, the more density you will have, and then of course the accuracy will somewhat related to the density of the material. And then the other way that affect the accuracy very significantly is the slice height. The thicker the slice height, the less accuracy will be. Imagine if you want to print a sphere, if you have a very thick slice, the sphere surface will not be as smooth as you want it to be. It will feel like very rough. If we decrease the slice height to the max, to the minimum thickness, which is 0.005 inches, the surface will feel very smooth, almost like a real sphere. So now this two part here is what we just see on the software screen. It takes about 3.5 hours to print all this, and as you can see, it looks exactly the same as you can see in the computer. And then for this is a functional part. As a higher density, you can see you can spin the bearing freely, and that's what amazes about the 3D printing technology. You can actually print functional part like this. 3D printing technology can give a lot of opportunity for the designer to actually see their part before they're actually producing the part. Especially is important in manufacturing, in the industrial. This 3D printing allows them to prototype their product and reduce the designing cost. It will be very beneficial for every single designer out there to have the opportunity to using this technology.